Okay, this is lesson 5.5. I do think that it will be on your midterm, okay? And I want you to remember that I made the quiz look as much like a midterm as I could, okay? This lesson's going to take about 50 minutes, 50, and the first probably 25 to 30 minutes is not even going to be doing the problem that you're going to have to do. It's building up to doing the problem. So I'm going to give you lots of little directions and teach you lots of different things, and then we're going to pull the whole thing together, okay? All right, here we go. So the first thing we're going to do is we're going to do a long division problem, okay? So the remainder of this division is what? So you take the outside, which is an x minus, or you take the bottom, which is an x minus 1, and you put it on the outside. Okay, now freeze right there for just a second, and I need you to remember that on whatever's on the outside and then also whatever's on the inside, you have to have that biggest exponent, everything down from there, plus a constant. So we have an x to the first and we have a constant, so we're totally good to go. The top is going to be written on the inside. Your exponents are 3, 2, 1 constant, so I'm not missing anything. If I was missing anything, I would have to fill in like a 0 and then, you know, whatever, like if it was an x to the second, a 0x squared. Nothing's missing, okay? What do I multiply by x to get 3x to the third? That's 3x to the second. Then I distribute and I get 3x to the third minus 3x to the second. Change my signs. First terms cancel. A negative 5 and a positive 3 is a negative 2 x to the second. Tell me what to do now, guys. Bring down the 3x. Good. Then you start all over again, right? What do I multiply by x to get a negative 2x to the second, a negative 2x? Distribute, you get a negative 2x to the second plus 2x. Change your signs. First terms cancel. 3x minus 1 minus 2x is 1x. Bring down the negative 10. What do I multiply by x to get x, which is, that's a 1. Distribute, I get x minus 1. Change your signs. First terms cancel, and you get a negative 9. Now, you have to listen to all the details I tell you, okay? I'm telling you, when I took the final last semester, I was like, there are so many details that these people have to remember. And if you forget the details, that's where the struggle comes. So here's an example of one of those details. If they ask you what is the result of long division, sometimes they say it like that. If they say it like that, you guys, they want the whole answer. So it's 3x to the second minus 2x plus 1. And then your remainder minus 9 is its own separate term. So you go minus 9 over x minus 1. So that would be the result of the long division, or the answer, okay? The remainder, if you write it like this, negative 9 over x minus 1, this is a 3-point question. They take off 2 of the 3 points. It's brutal. You did basically the whole thing correct, but you wrote it as a fraction and you weren't supposed to. So just remember, if they just ask you for the remainder, it's just the number with no fraction, okay? Okay, now look what they're doing right here. They want you to find f of 1. So guys, look, if I take the bottom, which is x minus 1, and I set that equal to 0, I get x equals 1. That's where that number right there came from. So now what they're asking me to do is to take the top and put a 1 in there. So it's 3 times 1 to the third minus 5 times 1 to the second plus 3 times 1 minus 10. Now you could put it in your calculator exactly the way you see it. I know 1 to the third, 1 to the second, and 1 to the first are all 1. So I'm not even going to write it. So I'm going to go 3 minus 5. I'm not even going to put it in is what I meant. 3 minus 5 plus 3 minus 10 equals, and I get a negative 9. So f of 1 is negative 9. Look what happens, you guys. If I take the bottom, set it equal to 0, plug it in, what I get is my remainder. That's true, okay? That's called the remainder theorem. It's right there. So if you divide by x minus c, ours was x minus 1, set that equal to 0, you get a c, plug in the c, and you get the remainder. That's all that's saying, okay? Okay, this factor theorem is important. Up above, I'm just going to add a little example, okay? So if you have a factor of x minus 5, then you will have a solution. Sometimes they call it a root. Sometimes they call it a 0. It's also called an x-intercept. If you have a factor of x minus 5, then you have a solution of x equals, somebody tell me. X equals 5. Yeah, thank you. X equals 5. There was something else I was going to tell you right there. I can't remember. Okay. Oh, I know. And then if you do division, when you divide, if it truly is a factor, when you go through the process of division, you will have no remainder. If something is a factor, or x equals 5 is a solution, when you do long division, you will not get a remainder. Okay? Okay, example 2. Use the remainder theorem to find the remainder, and then the factor theorem to decide whether or not it's a factor. This is really pretty simple. Take x plus 3, set it equal to 0, and you get x equals negative 3. Then plug the negative 3 in. So write down negative 4 times negative 3 to the third, plus 5 times negative 3 to the second, plus 8. You guys, you can put that in your calculator exactly how you see it. You know what I do? I store it in. So I'm going to go negative 3, store, enter. And then when I put this in my calculator, I'm just going to put it just like that. And where I see an x, I'm going to go membar. So minus 4, membar, enter, raise it to the third, plus 5, membar, enter, x squared, plus 8, hit enter, and I get 161. 161 is the remainder. Is x plus 3 a factor? Somebody tell me. It's not. If it's supposed to be a factor, then what would I get as a remainder? Everybody tell me. I would get a 0. Good. Okay, let's do it one more time. X plus 2 equals 0. X equals negative 2. Plug in the negative 2. So it's 3 times negative 2 to the third, plus 6 times negative 2 to the second, minus 15 times negative 2, minus 30. Okay, so negative 2, store, enter. 3, membar, enter, raise it to the third, plus 6, membar, enter, x squared, minus 15, membar, enter, minus 30, enter, and I get a 0. Is it a factor, guys? Yes or no? Yes, it is. Okay, so listen what we know. We know that we have a factor of x plus 2, okay? We know we have a solution of x equals negative 2. Here's another thing I know. Guys, listen to this. See this right here? I'm trying to factor that. Now this one is actually not too bad to factor. Some of them are really bad to factor, actually impossible to start factoring on your own. But this is what I know. Guys, look. If I were to factor that pink stuff, it would be x plus 2 times 1 or 2 more things. X plus 2 would be present in the full factorization of that thing right there. That's what that means, okay? Who says I'm with you? I understand what you're saying to me. Okay, great. Okay, now we're going to do something called synthetic division, okay? At first, synthetic division might seem kind of confusing. Then you're going to quickly love synthetic division. It takes long division and cuts the difficulty level in like a fourth. It's so much easier than long division, okay? Everybody write this down for me. Parenthesis, 3x to the third plus 6x to the second minus 15x minus 30, close your parenthesis, divided by parenthesis, x plus 2, close your parenthesis. That I just wrote down is exactly the problem from question 2b. So now we're just going to do it a different way, okay? So look what you do. See that x plus 2? Set it equal to 0, you get x equals negative 2. That's the number that goes right there. That's where that came from, okay? You guys look at the first thing that's in the parentheses. I have a 3, a 2, a 1, and a constant, so I'm not missing anything. Now I'm going to write down the coefficients. So I write down the 3, and then the 6, and then the negative 15, and the negative 30. So that's the setup, okay? Now, everybody listen for just a second. One time I had a girl come up to me and say, I don't like synthetic division. I think it's difficult. I would rather do long division. Is it okay if I do long division? So the answer to that question is yes, but it's going to be 4 times more difficult and 4 times longer. And so I told the girl, it's fine, you can make your own choice. I really think you should just stick with synthetic and try to make it click in your head because it's so much easier once it clicks. It's really easy. Okay, see this 3 right here, guys? All you do is just bring that thing straight down. So the first number always just comes straight down. And then you take the 3 and you multiply it by the number in that little half box. So 3 times negative 2 is a negative 6. Now you combine 6 and negative 6 and you get a 0. Now take the 0 and multiply it by negative 2. 0 times negative 2 is a 0. Combine those two things, negative 15 and 0 is negative 15. And negative 15 times a negative 2 is a positive 30, and I'm good. I've just proven that x equals negative 2 is a factor, as a solution, pardon me, and that x plus 2 is a factor, okay? Now listen to this. See how this is a third exponent? The exponent is a 3. I did synthetic division 1 time. If you go 3 subtract 1, that gives you a 2. So that is, what's left is 3x to the second. There is no x. I could write plus 0x. That wouldn't do me any good. Minus 15. If I take that and multiply it by what I just divided by, that's the factorization. Now, it factors further, but my point is this. If I take those two things and I multiply them together, I get that right there. So the process of synthetic division helps me to factor something that is difficult or impossible to start factoring on my own. Synthetic division makes factoring easier. Who says I understand what you just said? Okay, beautiful. Okay, question 4. Just sit back for just a second and listen to this for a minute, okay? Is x plus 2 a factor? Okay, well, I could take a negative 2, plug it into that equation, and make sure I get a 0. If I get a 0, it's a factor. But I'm not going to do that because read the next question. Find all of the zeros. If I just plug in a negative 2, it's not helping me to factor that original problem. So instead of plugging it in, I'm going to use synthetic because synthetic starts taking that big thing and breaking it down into something that I can manage. Okay, so take the x plus 2, set it equal to 0, you get a negative 2. Okay, so write a negative 2 right there. Okay, and then look at this p of x. You guys, you have a 1x to the 4th. There is no x to the 3rd, so I'm going to put a 0. The x to the 2nd coefficient is a negative 7. The x coefficient is a negative 6. And I need to have a constant, so I'm going to put in a 0. Okay, now I'm going to draw my line underneath. The 1 comes straight down. 1 times negative 2 is negative 2. A 0 and a negative 2 is a negative 2. A negative 2 times a negative 2 is a positive 4. A negative 7 and a positive 4 is a negative 3. A negative 3 times a negative 2 is a positive 6. Negative 6 plus 6 is a 0. 0 times negative 2 is a 0. And I have no remainder. So the first question is x plus 2 a factor? Someone tell me the answer. Yes, it is. Why is the answer yes? Somebody tell me. No remainder. Beautiful. So this is x to the 4th. I did synthetic division 1 time. 4 subtract 1 is a 3. So this exponent has to be an x to the 3rd. So now I have a 1x to the 3rd minus 2x to the 2nd minus 3x. I could put plus 0. That doesn't do me any good, so I'm not going to. And then I have equals 0. Why did I set it equal to 0? Because I'm looking for the solutions. If you're looking for the solutions, you have to set it equal to 0, okay? Tell me what you would do to that. Just shout that out. What would you do? take out an x, right? GCF. So take out an x, and you're left with x to the second minus 2x minus 3. Please don't forget your equals 0. Take out an x, or that x is out there. The x to the second is going to split to x and x. The 3 goes to a 3 and a 1. Signs are different because it's the negative. Okay, looks like that. Set each of those equal to 0, and I get x equals 0, negative 1, positive 3. And my answer is wrong. Say it really loud, Jackson. And a negative 2. They want all of the zeros. I know if x plus 2 is a factor, x equals negative 2 is a 0. Another reason I know that I probably am missing one, guys, look, that's an x to the 4th, so I should have 4 solutions, okay? Everybody freeze for just a second. By the time you take the midterm, everybody just freeze for a second, okay? By the time you take the midterm next Thursday, you're going to be like, give me this test and let me take it because I'm sick of studying for it. Like, I want to be done. And you're going to say, plus I'm so ready. Like, I can do this any day of the week. I'm ready, okay? You're going to take your test, by the way, which is an hour and a half long, and class is an hour and a half long. Well, that doesn't give me any time to pass out tests and collect homework and stuff like that, which if we hurry, maybe would take 5 minutes. So you might have to go late to your 6th period class if you still need another 5 minutes, okay? So you're taking your test, you're done, and there is still 15 minutes left before the time is up. Should you turn your test in and space out for 15 minutes now that you've studied for about 15 hours for this test? No. What should you do? Tell me. Checking, 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 go over it, redo it, do everything you can. Look at this question. This question is 100% checkable. If this question were on your test, you could walk away from that midterm and say, without a doubt, I got that problem right. There's no question. I have to get you thinking in that way to check, check, check every single thing that you do. Someone tell me how to check this. Plug it in. When I plug it in, what should I get? A 0, okay? Every person in the room is going to do this with me, okay? I want you to go through this process of checking, okay? Here we go. Everybody go 0, store, enter. Membar, enter, raise it to the 4. Minus 7, membar, enter, x squared. Minus 6, membar, enter, enter. It works. The other ones are so fast. Negative 1, store, enter, up, enter. It works. 3, store, enter, up, enter. It works. Negative 2, store, enter, up, enter. I know I got that problem right. I plugged every one of them in, and I got a 0 for every single one. Who says I understand? Let's see. Raise your hand. Let me see. Okay, great. Here's question 5. Show that these are factors and find all of the remaining real factors. Okay, everybody freeze for 2 seconds. Set x plus 2 equal to 0. I get a x minus 2 equal to 0. I get a 2. I could plug in a 2, make sure I get a 0. I could plug in a negative 3, make sure I get a 0. Does that help me to find the next part? It doesn't help me. Guys, everybody look right here. If someone asked you to factor that, could you factor that? Right now, could you factor that? No. It's very complicated, right? You've got an x to the 4th. You've got 5 terms. It's super complex. So I'm going to do synthetic division. And synthetic division is going to have me take that big thing that I don't know how to factor and break it down into something smaller and break it down into something smaller until I can deal with what I've got and I can factor it or use the quadratic formula to solve it. Okay? Who says I understand? Raise your hand. Beautiful. Okay. X minus 2 is a factor. So x equals 2 is a solution. X plus 3 is a factor, so x equals negative 3 is a solution. It does not matter, bless you, which one you start with, okay? So let's just start with the 2. Look at that yellow highlighted equation. So I have a 4, a 3, a 2, a 1, a constant. I'm not missing anything. So I'm going to go 2, 7, negative 4, negative 27, negative 18. Everybody freeze right here. The problem told me those were definitely factors. So I need someone right now, before we do this, to tell me what is going to happen as I do this synthetic division. Freeze for a second. A 0. No remainder. Yeah. If I get a remainder, I did something wrong. Because I know it's a factor. So I know it's a solution. Okay. 2 comes down. 2 times 2 is 4. 7 plus 4 is 11. 11 plus, or times 2 is 22. 22 subtract 4 is 18. 18 times 2 is 36. A negative 27 and a positive 36 is 9. 9 times 2 is 18, and I'm feeling really good. Okay, it's a nice little check in the middle of the problem. Am I doing this right? Okay, now I'm going to do a negative 3. Listen right here. Everybody listen for a second. I've started to break this guy right here down into something smaller. If I do this, okay, if you're writing, I really want you to listen, okay? If I do this and I start back over from the beginning, that's not helping me to make it smaller, smaller, smaller. I went from something smaller back to something bigger. So that doesn't do me any good. So now I'm going to stack it. So I'm going to put a negative 3 right here, and I'm going to do another one right underneath it. So I'm getting it even smaller. So the 2 comes right down. 2 times negative 3 is a negative 6. 11 subtract 6 is 5. 5 times negative 3 is negative 15. 18 minus 15 is 3. 3 times negative 3 is negative 9. And I'm feeling so confident. Okay? So I've shown that those are factors. Guys, listen. This biggest exponent is a 4. I did synthetic division twice. 4 minus 2 is a 2. So that's got to be an x squared. So now I have 2x to the second plus 5x plus 3. They want the factors. They don't want the solutions. They want the remaining factors. So I'm not going to set it equal to 0. I'm just going to try to factor it. Okay? So this is going to go to a 2x and a plain x. The 3 is going to split to a 3 and a 1. Signs are the same. They're both positive. So it totally factors. So the remaining factors are 2x plus 3 times x plus 1, and I'm done. Okay? Now I'm going to add a few things right here. If they asked you for the full factorization, okay, you would write the 2x plus 3 and the x plus 1. What else must be there, everybody? Yep, x minus 2 times x plus 3. You guys, if you multiplied those 4 things out, you would get exactly that yellow equation. So I just factored it. Synthetic division helped me to factor something that was difficult to factor. If they asked you find all of the zeros or the roots or the solutions or the x-intercepts, they all mean the same thing. Set each of those equal to 0. Set 2x plus 3 equal to 0. The 3 comes over and becomes a negative. Divide by 2. The x plus 1 gives me a minus 1. The x minus 2 gives me a positive 2. The x plus 3 gives me a minus 3. That's my answer, and I'm done. Okay? All right. This is what the problem really is right here. So I told you it'd take a while to get us set up to do the real deal. Here's the real deal. Okay? Okay. Everybody just kick back, okay? Do me a favor and don't write right now, okay? Do me a favor and just look forward for a second, okay? Okay, this equation that I'm dealing with on example 3 is a cubic, okay? So maybe it would look something like this. And what I'm looking for are the zeros. Someone tell me where on that graph my zeros are. Tell me where they are. Zeros, roots, solutions. What's the other one we wrote? X-intercepts. So where are my solutions? They are here and here and here. Okay, now listen. Back in secondary 3, last year, if you had this problem, all you had to do is put it in your graphing calculator, look at the graph, find a nice x-intercept, nice meaning 1, -4, 0, well 0 would be kind of tough, but anyway, a nice number, right? A solid number, not like a 1.3 or something, right? Look for a nice one and start doing your synthetic division, okay? But I don't have a graphing calculator. I don't get that liberty, so I don't know where to start, okay? Look at this thing right here. I'm trying to solve that, and I can't factor it. I cannot factor that thing. And I don't have a graphing calculator to help me start, okay? So what do? I have to come up with some possibles. That would be step A, okay? So here's how you do it. Everybody write down the word constant. The constant is the number that has no letters. That's a 3. And then I want you to write factors of constant. The factors of the constant, you guys, are the numbers that go into 3. That would be 1 and 3. Then I want you to write down the words leading coefficient. This is what the leading coefficient is. See, that biggest exponent is a 3. The number in front of that is a 2. So that's it. And then we have to write down the factors of the leading coefficient. What numbers go into 2? 1 and 2. Okay, the factors of the constant go on top. Okay, so look what you have to do. You have to put 1 and 3 on the top. You have to put 1 and 2 on the bottom. Now that is not how you write your answer. I have to pair up everything on the top with everything on the bottom. And I want you to do it in a systematic way so you don't get confused. Okay, so here's what I do. I start with the 1 and I put it over 1. Well, 1 over 1 is a 1. Then I keep the 1 on the top and I change the number on the bottom. So that would be 1 over 2. Now I've used all the numbers on the bottom. So now I'm going to change the top number. So I'm going to go 3 over 1. That's a 3. And then I have 1 left. That's 3 over 2. So I've done every combination of the top paired up with the bottom. Okay? Now, it could be the plus or minus like that. This is a true story. I used to teach pre-calc a long time ago. And in pre-calc, this is how we wrote our answer. That I had 8 possible zeros, positive 1, negative 1, positive 1/2, negative 1/2, positive 3, negative 3, positive 3/2, negative 3/2. I had my students write it like that. Weber State did not like it, and they took off a point off of all my students. And you're like, a point? Well, that's not a big deal. Well, yeah, if it's worth 100 points, that was a percentage, so it wasn't fun, right? What do you think they didn't like about what we wrote? Any guess? It looks like it's just plus or minus 1. The plus or minus applies to everything. How do I show that it applies to everything? I put parentheses right there. You're exactly right. Good. Okay, let me tell you what that means. There are now 8 numbers, those 4, the positive and the negative, that might be solutions. So it gives me a start. They might not work, and there will quite likely be more that aren't listed, but at least I've got an idea of what they could be. Okay, everybody grab your calculator. Let's try the 1. Everybody go 1, store, enter. Put it into that pink highlighted equation. 2, membar, enter, raise it to the 3rd, plus 3, membar, enter, x squared, minus 8, membar, enter, plus 3, enter, and it worked. How do I know it worked? What made it work? I got a 0. So right here where it says rational zeros, I want you to write x equals 1. That's what I'm going to highlight. There might be more, so I'm not going to highlight it yet. Now I'm going to do synthetic division with a 1 and start breaking this thing down. I have a 3, a 2, a 1, a constant. I'm good. 2, 3, negative 8, 3. This is a big question I'm asking you right here. What is going to happen right now during this process of synthetic division? No remainder. 0 remainder. If I get a remainder, freeze and fix your mistake because something's wrong. 2 comes right down. 1 times 2 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 8 and a positive 5 is a negative 3. Negative 3 times 1 is a negative 3. And I'm feeling so good. Okay? Listen, guys. This is a third. So this is a second. Once I get it down to a second, I know I can stop looking. Because if I have a second, I can either factor it or quadratic formula to finish it up. Okay? So everybody write down 2x to the second plus 5x minus 3 equals 0. I'm setting it equal to 0 because I'm finding the solutions. I'm going to try to factor this. So it's going to go to 2x and a plain x. The 3 goes to a 3 and a 1. That gives me 6 and 1, which subtracts to give me 5. So it totally works. The positive goes there. The negative goes there. So my other solutions are x equals. The 1 comes over and becomes a positive, divide by 2. The 3 comes over and becomes a negative. So my solutions are 1, comma 1/2, comma negative 3, and they are all rational. Rational means can be written as a fraction. That's the easy definition of rational. Well, 1 is 1 over 1, negative 3 is negative 3 over 1. So on this particular problem, the other zeros are none. There are no other zeros. Here's what would go there if we had one. A square root. Okay, when would we end up with a square root? If we had to use a quadratic formula, right? And or an imaginary. So anything weird, okay, that would be considered an other zero. Okay, now, everybody freeze right there. Is this problem checkable? Tell me that. Yes or no? 100% checkable. The other thing I want to say is this. It is not going to be this easy. That's too easy, right? They all were rational. It was very simple, okay? 7 and 8 is really what this thing is going to look like, just so you know, okay? By the way, freeze for 2 seconds. Weber State used to make us split them between rational and other. They haven't been doing that so much. So sometimes they say, find the possibles and then find all the solutions. And they don't have you differentiate between rational and other. If they don't have you differentiate, just find them. If they do have you differentiate, this is how you do it. Okay? Okay, let's do the possibles. Everybody write constant. And it is a 4. The factors of the constant are 1 and 2 and 4. Then write down leading coefficient. Biggest exponent is a 3. The number in front is a 2. So the factors of the leading coefficient, what goes into 2? 1 and 2. So the constant factors go on top, 1, 2, 4. The leading coefficient numbers go on bottom, 1 and 2. That is not how you write your answer. Do 1 over 1, 1. 1 over 2, 1/2. 2 over 1, 2. 2 over 2, 1, but I already wrote a 1, so I don't have to do that. 4 over 1, 4. 4 over 2 is a 2, but I already wrote it. Put parentheses around it, plus or minus. There you go. That's my answer to part A. I have 8 possible things that will work. Some will work, some won't work, okay? 1, store, enter. 2, membar, enter, raise it to the third. Plus, membar, enter, x squared. Minus 9, membar, enter. Plus 4, enter, didn't work. Why didn't it work again? What would I have gotten if it would have worked? A 0. I didn't get a 0. Let's do a -1. -1, store, enter, up, enter, didn't work. I'm going to skip over that 1/2. If I can avoid it, that would be nice, right? 2, store, enter, up, enter, didn't work. -2, store, enter, up, enter, didn't work. 4, store, enter, up, enter, didn't work. -4, store, enter, up, enter, didn't work. So now I have to use the 1/2, okay? So I'm going to go 0.5, store, enter, up, enter, and it works. So right there where it says rational, I'm going to write down x equals 1/2. If you want to, highlight it, because I do have a problem with people not actually answering part B. They do the whole synthetic division, but they never say x equals bam are my rational zeros. So just be careful you write that, okay? Don't let the 1/2 freak you out, and Weber State loves to have you do fractions on this, okay? 3, 2, 1 constant, I'm not missing anything. So I have a 2, a 1, a -9, and a 4. For about the 4th time, what's going to happen right here? No remainder, right? 2 comes down. Multiplying by 1/2 is not scary. Multiplying by 1/2 is the same thing as dividing by 2. Yep. So 2 divided by 2 is 1. 1 plus 1 is 2. 2 divided by 2 is 1. -9 plus 1 is -8. -8 divided by 2 is -4. Everything's great. Now listen, that was a third. So now I've got that down to a second. Once it's down to a second, I can stop. So it's 2x to the second plus 2x minus 8. I'm trying to solve it, so I have to set it equal to 0. Tell me what you would do right here. Take out a 2, right? Take out a 2, and you're left with x to the second plus x minus 4 equals 0. The 2 does nothing to the remaining solutions, okay? Look at this right here. Can I factor that? No, okay? Everybody freeze right here. I need to tell you something. Every person in this room is so smart. You are so smart. I would be surprised if someone could answer this question. I would love it if someone could answer this question. Listen, this is going to save you a headache, okay? Listen. If on one side of my paper, I did the quadratic formula, which is what I'm going to have to do, using A as a 2, B as a 2, and C as a -8. On the other side of my paper, I did the quadratic formula with A being a 1, B being a 1, and C being a -2. I did them side by side. How would the result of those two problems compare to each other? Tell me. Julian, you're so smart. Say it again.
It's the same.
The same exact thing. Exactly the same. So why would I ever use the big ones? The big ones make it so much tougher. So please don't use 2, 2, and 8. If you can take something out, take it out, and then use the numbers on the inside. Okay? Wonderful. Okay, so now I'm down to question C. If it doesn't factor, there are going to be other zeros. So everybody go x equals -b, that's -1, plus or minus the square root of b squared, that's 1 squared, which is 1, minus 4 times a, which is 1, times c, which is a -4, all over 2 times a, that's 2 times 1, which is a 2. Freeze for a second and listen to this. If you go ahead, you're missing little details that are very important. Can I put this guy in my calculator in one big swipe the way I've been doing? Is that acceptable? Read the question. Somebody guess.
Yes.
If I do that, what's the answer going to look like on my calculator? Probably. And what's it going to be? A decimal. And is it okay to write this in decimal form? It's not. Why not? They didn't tell me to write it in decimal form. So do not put that thing in one big swipe. You can't do it. If it says decimal, do that. It did not say decimal. Do not do it. Okay, grab your highlighter. Well, I don't care if you highlight, but I just want you to look right here. See that stuff that I highlighted in pink? People mess up on that all the time. All the time. So when you get to this point, I'm begging you to grab your calculator and just stick that in your calculator, okay? So everybody go 1 minus 4 parenthesis 1, close it, new parenthesis, negative 4, close it, enter, and you get 17. So I get x equals negative 1 plus or minus the square root of 17 all over 2. Look, guys, there's 2 answers there. There's 1 answer right there. I have a third. I'm done with the problem. I'm done. Now, we're not going to stop talking about it. This is what I think it's going to look like. Okay, like this problem, which I think is okay. Raise your hand if you're like, I totally followed you. I'm good. Okay. What are we going to do right now? What am I going to make us all do? Plug it in. Check it. Okay. Everybody go 0.5, store, enter. Go to the original equation and go 2, membar, enter, raise it to the third, plus membar, enter, x squared, minus 9, membar, enter, plus 4, enter, and I got it. Now, let's check these. Look what you're going to have to do. Follow with me closely. You have to add parentheses around the top. Okay, so everybody go parenthesis, negative 17, plus, oh, negative 1, thank you. So go parenthesis, negative 1, plus second, x squared, 17. Now look at your screen. How many closed parentheses do I need on this one? 2. 1 for the radical, 1 for the top. Good. Then go divide 2, store, enter.
Do you not need a parenthesis on top?
No, because you only have one thing down there. But if you do put parentheses, Jackson, it's fine. You don't need them, but if you do it, it's fine. Then go up, up, enter, it works. Now hit up 2 times. Move to the right until you're in front of that root. Make it a negative. Hit enter. Then go up, up, enter. I just checked both of them. I walk away knowing there is no question I got that thing right. Okay? Okay, let's do question 8. Okay, look right here. Do I know how to factor that monstrous thing? No, I do not know how to factor it. It's huge, and I've got a 5th. Okay, let's write down what goes into that constant. 1, 2, 4, 8, and 16. I write them in numerical order because I don't want to miss anything. Okay, the leading coefficient is a 1. What goes into 1? Just 1. That would be like dividing by 1, which doesn't change anything. So I'm just going to add parentheses, put a plus or minus in front of it, and I'm good. Okay? Now I'm going to start testing. Okay? Grab your calculator. Everybody go 1, store, enter. Membar, enter, raise it to the 5th. Minus 5, membar, enter, raise it to the 4th. Plus 12, membar, enter, raise it to the 3rd. Minus 24, membar, enter, x squared. Plus 32, membar, enter, minus 16, enter, and it worked. Okay, so everybody write x equals 1. Now I'm going to start breaking that big thing down by doing synthetic division. So put a 1 right there. 5, 4, 3, 2, 1, constant. I'm not missing anything. So 1, negative 5, 12, negative 24, 32, negative 16. Draw my line. The 1 comes down. 1 times 1 is 1. Negative 5 and 1 is a negative 4. Negative 4 times 1 is a negative 4. 12 minus 4 is 8. 8 times 1 is 8. Negative 24 plus 8 is negative 16. Negative 16 times 1 is negative 16. 32 minus 16 is 16. 16 times 1 is 16. I'm feeling really good. Okay? What I would like you to do right here is to freeze for a second. Okay? Listen. My biggest exponent is a 5. I've now taken it down to a 4. So I have x to the 4th minus 4x to the 3rd. Don't write this down. Plus 8x to the 2nd minus 16x plus 16. Here's my question to you. Do I know how to factor that thing?
No.
No. So I have not broken it down enough. It's not small enough for me to deal with it. So what do? Everybody tell me. Find another one. Yes, let's find another one. So everybody go, -1, store, enter, up, enter, doesn't work. 2, store, enter, up, enter, and it works. So see that x equals 1? I'm going to do a comma and put a 2. Now I'm going to stack it. So I'm going to put that 2 right there. 1 comes down. 1 times 2 is 2. -4 plus 2 is a -2. A -2 times 2 is a -4. 8 minus 4 is 4. 4 times 2 is an 8. A -16 and a +8 is a -8. -8 times 2 is a -16. I'm feeling so good. What I'm about to say to you right now might be confusing. So I need you to really listen. I'm going to show you a trick. Okay, watch. I did synthetic division twice. 5 subtract 2 is a 3. So this is an x to the third. Okay, don't write this down for a second. X to the third minus 2x to the second plus 4x minus 8 equals 0. Do I know how to factor that? Maybe. Watch this trick. Look at 1 and 2. Look at 4 and 8. Compare the 1 to the 4. Which one's bigger? 4. Can I take something out of a 4 and the same thing out of a -8 to turn the 4 into a 1 and the 8 into a 2? If I took out a 4 right here, 4 divided by 4 is a 1. -8 divided by 4 is a -2. If I can turn these numbers into these numbers, I know I can factor. So that's just a little trick, okay? So I don't have to keep looking. I can quit. I know this thing's going to factor. So go ahead and write that down now, okay? X to the third minus 2x to the second plus 4x minus 8 equals 0. Okay? Now let's factor this. So the x to the third, guys, is going to split to an x to the second and an x to the first. Please don't forget your equals 0. Now look at the x to the second, you guys. Whatever goes here will be multiplied by the x to the second. And I need a -2x to the second. So I'm going to go minus 2. Whatever goes here is going to be multiplied by the x. And I need a plus 4x. So that would be a plus 4. Okay? Now, when you do that little trick, when you do that factoring, take a second and make sure that a +4 times a -2 is a -8, which it is. Okay? Now, this x minus 2 gives me a 2, and I already have that written down. This x squared minus 4 doesn't factor. So I'm going to have to come down here, x squared plus 4, sorry, and write x squared plus 4 and set it equal to 0. Grab your highlighter and highlight x equals 1 and 2 on part B because those are the two solutions. Make sure you write that down. X equals what in part B? Okay? Look at question C now. I could use the quadratic formula. I would never use the quadratic formula. There's a much easier way than quadratic formula. What can I do, everybody? What would you do to solve it?
I just square, subtract 4 and then square.
Move your 4 and then square root. Yep. So you're going to go x squared equals -4. Now I'm going to square root it, and I get x equals, someone tell me what comes right after the equals, plus or minus, and then what's the square root of a -4? Square root of 4 is 2, and then you have an I, so 2i, okay? There's my part C. Here's my part B. I'm done with the question, and now I'm confused. Everybody look. I have an x to the 5th. I'm supposed to have 5 solutions, and I only have 4. I have a 1, a 2, a 2i, and a -2i. I have not done anything wrong. Where is my 5th solution?
0.
Say it again.
0.
No. You know how you know it's not a 0? Because if every single one of those terms right here had an x in it, you would have a solution of 0. But the 16 doesn't have an x, so it's not there. I haven't done anything wrong, but I have lost a solution somewhere. Where is it? You guys are so smart. Every class period, someone has figured it out. Look at it and think about it. What is it, Sam? You're right. Tell them what you're talking about. See, I knew you guys were so smart. Tell them, Sam.
So you used the 2 the first time.
This 2 right here gives that. This 2 right here gives it again. So x equals 2 is a solution twice. If I were to graph it, which we are not going to graph it, but if I did, when it came up to the 2, it would bounce back down because 2 is a solution twice. Who says I understand that? Okay, awesome, Sam. Okay, these last 3 problems, they're going to look really bad at the beginning. They are not tough at all. I do not think they're going to be on the quiz. I do not think that they're going to be on your midterm. I have to teach you because it's part of the course, but I don't think the chance of that is very high of these being on there. The last problems we just did, like number 8 and number 7, there's about a 100% chance you're going to see that. Okay? Okay, question 9 is really simple. Show that there is a 0 between 2 and 3. Okay? Watch what we're going to do, guys. We're just going to make a table of values. We're going to let x be a 2, and then we're going to let x be a 3. Okay? Grab your calculator, and everybody go 2 store enter. Put it in the equation. Membar enter, raise it to the 3rd. Minus 2, membar enter. Minus 5, enter, and I got a -1. Let's do a 3. 3 store enter, up, enter, and I got a 16. Okay, now I want you to think about this. Draw an xy axis. Okay? If x is 2, then y is -1. If x is 3, then y is clear up here, and I know that's not high enough, but you get the idea, at a 16. In order to graph this equation, I have to connect the dots. It has to be continuous. Well, look what's going to happen. If I connect those dots, you've got to cross the x-axis, right? If you cross the x-axis, then you've got to have a solution right there where it crosses, okay? So basically, here's what you do. You find the y's, and if the y's have different signs, you know it's got to cross the x-axis between those points. Who says I understand? Great. Here's how you could write it up, okay? Everybody go, f of 2 is -1, comma, f of 3 equals 16. And then I'm going to say the graph must touch the x-axis between 2 and 3. That's it. Okay? Question 10 and 11, they look terrible. They're nowhere near as terrible as you think. Okay? Find k such that f of x has a factor of x plus 1. Take the x plus 1, set it equal to 0, you have a -1. Look at your exponents. 3, 2, 1, constant. I'm not missing anything. In front of the x to the 3rd is a 1, so put a 1. In front of the x is a 2k, or pardon me, in front of the x squared is a minus k. Who cares that there's a k in there? Just go with it. In front of the x is a 2k, and the constant is a -1. Draw your line. 1 comes right down. 1 times -1 is -1. Negative k minus 1, I can't combine those, so I'm just going to go negative k minus 1. Multiply by a -1 and it changes the signs. So I have k plus 1. 2k plus 1k is 3k, and you've still got the plus 1. 3k plus 1 times a -1 is -3k minus 1. Add those together, -3k minus 2. This -3k minus 2 is the what? The remainder. And if this really is a factor, then the remainder is supposed to be 0. So just go negative 3k minus 2 must be 0. Negative 3k must be 2. Divide by negative 3. K must be a negative 2/3. And I'm done. Okay, I want to change question 11 so that the remainder is 10, not 3. Okay, find K such that the remainder, can you give me 1 minute? I'm going to go really fast. When dividing this by x minus 1 is 10, really fast. X minus 1, let it be a 1. In front of the x to the third, you have a 2. X to the second minus 3k. X, k, constant, negative 2. Draw your line. 2 comes down. 2 times 1 is 2. That gives me negative 3k plus 2. Times 1 is negative 3k plus 2. 1k minus 3k is a negative 2k plus 2. Times 1 is negative 2k plus 2. The plus 2 and minus 2 cancel out, so I have a negative 2k. The negative 2k is my remainder. It's supposed to be 10. Divide by negative 2. K must be negative 5. Okay, that's it.